Study today is of slowly. Don't read everything part by part. We will study. Today we'll do qualitative analysis. So qualitative analysis, also known as chemical analysis. What is this all about? Whenever you are interested to know what elements or what groups, okay, we will use a word called group. Okay, first of all, let us understand. If you have a ionic compound, let's take one ionic compound. Let's say sodium chloride. So sodium chloride as an ionic compound will be composed of two ions, a cation and an anion. Sodium is the cation and chloride is the anion. The cation is always the metallic ion, except one, which is ammonium. Ammonium is a non-metallic cation. Okay, so we'll have a cation and we'll have an anion. And when you go to higher classes, you will find that sometimes when you study complexes and other things, you will have two anions also. So anions, when they are actually present as a single atom elements anion, like say chlorine Cl minus, we call it chloride. Bromine Br minus, bromide. So you can call it an anion. Now, when this is a polyatomic anion, in chemistry, we also call it as a radical. Polyatomic means more than one kind of atom. CO3 2 minus, carbonate. You can write down CO3 2 minus is carbonate. Okay, SO3 2 minus is sulfate. NO3 minus is nitrate. And I hope, do you know how to get to understand whether it should be SO4 2 minus or 1 minus? Always think of the acid, H2SO4. So 2 hydrogen means 2 plus, that means SO4 should be 2 minus. Have you understood? So our quest in this part of the chapter is that given a sample of a substance, that substance can be a mixture also given to you. Mixture means two salts mixed together. So that's called, as I told you, like what I used to do in our lab days, double salt. Double salt is basically a mixture. And if you have a single salt, you are getting a pure substance, which is a compound. So the compound is going to be comprised of what? The compound will have a cation and an anion. And if you are having a double salt, so you will have a group of cations and group of anions. Our job is to understand here that given a sample, what all substances are present in it. We are going to test here. And we are going to test and check that what are the elements present in it, and the elements will be present in the form of ions, metallic ions or say cations, or non-metallic ions such as anions or as radical. Have you understood? This particular procedure or the study that we do for this is known as chemical analysis, and more so it is known as qualitative analysis. You are going to study, you're going to hit the quality parameter of that material. Make yourself very clear, in this part of chemistry, you are no way interested in quantitative data at all. There is no quantitative data. Quantitative data is in quantitative chemistry, which is like molarity, concentration, which you used to find out, titration, those all used. Then you'll say, sir, in last class you spoke about titration. I spoke about titration where I was discussing about measuring apparatus. Have you understood? Experimental techniques. We are all in a lab. So in a lab, we might be doing data we might be doing researches or investigations which relate to data, quantitative data, and not relate to quantitative. Our study today is nothing to do with quantitative data. We're only going to deal with the qualitative aspect of a substance or a sample given to me. And the way you get to know about what is present in it, that branch is known as chemical analysis or qualitative analysis. Is this clear? Okay. We will not hit any data. In this part, whatever we're going to study today, there will be nothing called 25 centimeter cube of this gas. Aisa kuch nahi hoga. Rather, you will hear about greenish gas, fuming gas, okay, gas which was supporting combustion. These sort of things we'll hear. So how do we perform this? It also, there is not a fixed rule by which you will be performing this type of analysis. So it all depends upon what is the sample given to you. Now, there might be two ways that we go to check something. A sample is given to me, and my interest is to find out what all things are present in the sample. Another way that I would, don't read now, otherwise you'll get biased. Listen like a story, and then if there's anything missed out, I'll cover. So one is a sample is given to you. You might be interested to know what is there in it. Another is a sample is given to you, and you are checking whether this thing is present in it or not. Are you getting the difference of both? One is I give you a sample and you try to find out what is inside it. Another is I give you a sample and you're going with already a prejudice mindset. Is copper present in it? Now, copper won't be present as copper. Copper will be present as copper ions. Is chlorine present in it? The chlorine will be present as chloride ions, right? So we get a sample, and the sample will decide the techniques and the complexities. Why we say complex? because certain techniques are very easy. And out here, the way you will focus as a start to experimental techniques, you will be now going through the easy phase of it only. So you need not bang your head too much. Now, one of the ways we do are called spot test. Spot test means like the way a guy buys fish. You look at the fish and you say whether the fish is fresh or not. You look at the vegetables and you will just perform some test. What is the test you'll perform with when you buy potato? What is the test you'll perform? You tell me. You'll pick the potato in your hand and you'll just physically check it whether there is any worms in it, any rotten portion, any cut, any unwanted cut. Another thing that we can do, just use your common sense. Don't you think you will also smell it? You smell a fruit also. So odor and smelling is one very important aspect in lab. If you are good with reagents and all, many things you can disclose just by smelling it. For example, there are some smells which once you are in lab, you will be very particular with it, like the smell of chlorine gas. I can't tell you how it is. The smell of ammonia, because you have not smelled. If you want to smell ammonia, just take out the red bathroom cleaner and just try to smell it a little bit. It will give you a little bit of ammonia. Ammonium hydroxide will be there. So it gives you a smell of ammonia. So take a salt, and if the salt after taking in your hand itself starts smelling like ammonia. So first of all, that hint comes in my mind. Ammonia will be present as ammonium ion. Write that also, NH4 plus. Ammonia gas is NH3, and ammonia, when it is present as an ion, is called ammonium ion, which is NH4 plus. And also mention that this is the only non-metallic cation. So tell me, you get a salt and you start smelling and you smell a little bit of ammonia, or you take the salt and you little bit heat it, and if you get ammonia is a gas, they say that if a person gets unconscious, then some people will take a small handkerchief and they'll just dip it in little bit of aqueous ammonium hydroxide and they'll make you smell. If you have little bit senses also left, you'll open your eyes. It's that strong. Even a snake also rises up. So ammonia, you cannot escape from the smell of ammonia. So given a salt, if I just lightly say warm it in my hands also, and I just mix it like this and I can smell ammonia, so my doubt hinges ammonium ion is there. So when I'm trying to do is chemical analysis, I will straight away go and try to hit the test for ammonia. Ammonia to hai isme lag hi raha hai. Or something I got which is bluish in color. My mind starts thinking copper must be present in out here. Greenish in color, maybe nickel must be. Brownish, maybe brown. Have you seen rock salt? Kala namak, which we eat. Rock salts in the form of crystals, not the powdered ones which you Zenzi must be using like from a bottle of catch. No, the big crystals which is available in a kirana shop. So they will be like broken bottles of cough syrup glass, brownish and red. Chances there iron will be there. So we'll test it for iron itself. Are you getting it? So certain tests are there which we do confirmation of presence of only elements on group, and we do them by spot test, right? No hard and fast rule. And then if you have a complex mixture, then we have to go by a systematic analysis. Initial steps does not need any apparatus. Initial step is always physical examination, color and smell. God has given us two organs, that is the eye and the nose. With these two also, you should be able to get to know what is presence. Now, when you do chemical analysis, there are two types of tests which we do. Certain tests are called preliminary tests. Looking at it blue does not mean that copper is 100% present. So what do I say? Copper may be present. It's a preliminary. And then when you go in higher classes, you will study, there are some tests which are called confirmatory test. Means once I do this test and this is performed and this is the result obtained, iske aage aur kuch nahi chahiye, necessary and sufficient. Have you understood? So first of all, it's all a hit and trial. First you will say this may be present, that may also be present. Then between the two, you will try to do one test and eliminate the other. So that's called a confirmatory test. So when we do a test of odor and smell, the color and smell, odor and smell means the same, you're actually doing a preliminary test. As students of grade 9 and grade 10 in IGCSE, this part is something that they will not much concentrate for you on your syllabus. I don't think they will be asking you any question on this. Maybe one question they may say that, Stella started to heat the salt and it gave fumes of smell of ammonia, which makes you understand that ammonium. Other than that, this part, though we have a chart, but that's not so significant. What is significant to you, we will discuss. There will be 5 charts which will be significant for us, right? Now, after that, what do we do? From importance from our syllabus, okay, So let's have a look at color and smell. This is the section of color and smell. Again, I'm saying from syllabus perspective, you won't get a question where they will tell you pale grain crystals. These are because these are all preliminary tests. So let's have a look at this. If you have a black powder, there is a chance that you may have carbon, may also contain oxide ions, as in copper oxide, CuO, okay, CuO, or sulfide ions, as in CuS. So how do you know whether it is black, it is copper or carbon? This is a preliminary test. This portion, nobody will judge you in an examination. Let's see the next one, pale grain crystals, pale green. They're saying iron might also be there. Even in brown also you can have iron. Dark green, nickel ions may be there. So how to use this chart? If I'm in a lab and I get a dark green crystal salt for whose chemical analysis is to be done, my first hint says what? Dark green means nickel might be present. My next step, what I should do? I will take that pinch of that salt and I'll carry a flame test for nickel. Doubt ho raha hai. Let's do the next round of test in it. If I get another flame test positive for nickel, another affirmation. And then if there is a conclusive evidence test, we will perform that. Is it understood to you? So in your exams, the type that you will be tested is, the question will not come directly from this chapter. There will be a constant, they'll give you a question, say on stoichiometry, and that constant, everything will be copper salt. However, the final mixture had a salt which on flame test gave you this. Now in flame test, what you should remember, I have marked them also from your syllabus perspective. Okay. So yellow brown crystals contain C iron. Yellow brown means this is ferrous ferric +2 +3 state. Yellow brown. Yellow brown means rust, the higher oxidation state. Smell of ammonia. This is something that is important for you. Smell of ammonia. Any gas, if any mixture, if it smells ammonia, that means ammonium ion might be present, and you can also heat and see. Now it's important is what is important for us from the syllabus perspective. So from the syllabus perspective, there are 1, 2, 3, 4, 5 things that you should be concentrating on. The first one is flame test and colors, flame colors. The second one would be that we would be seeing certain cations. We'd be trying to see cations, their behavior with sodium hydroxide solution, aqueous solution. Aqueous cations means solution, metal. There will be some metal salt whose solution will be given to you. Solution means solution in water. That is called an aqueous solution. So the cation is also in aqueous state. Cation means metal. Group 1, group 2, group 13, like that. Okay, no, you don't have group 13. So for you, group 3. Okay, now that it's test performed by sodium hydroxide. So the first one is flame. The second one is sodium hydroxide, dilute solution of sodium hydroxide. The third one is ammonia solution. Ammonia solution is same as ammonium hydroxide. Ammonia gets dissolved in water, so it's known as ammonium hydroxide. So the third one is ammonium hydroxide. Majority of the questions will come from these three. And there are 2 more left. So because 1, 2, 3, you were very biased towards only the cations. So the fourth one will be all about anions. And the fifth one will be about gases. There also we'll see what is important for our syllabus. थोड़ा आराम से पढ़ेंगे. पूरा कोई नहीं रट सकता इसको. And no idiot will remember this whole thing. Whenever you are in a lab, you'll also have it as a chart in front of you. You don't mug up the whole chart. Fine. Can we go ahead? This is spot test in the form of color. Not that much significant for you. Here, if something is significant, is this one, smell of ammonia. So they might give Stella on heating the salt, smelt fumes of ammonia. That means ammonium ion is present. Isme lekin one thing is confirmed. If any salt, dry smell wise smells of ammonia, ammonia has got a very particular smell. Now to give you a very bad example, if anybody, the example will be bad, but still you understand. If you go to public washrooms and all, okay, typically, and say people have ahiri pehle hasna shuru ho gaya. If you go to washrooms and say hygiene is not maintained, and there are like say urinals or washrooms out there, you typically have a gas which smells up because urine contains urea and urea will release ammonia. That's why there is an ammonia smell. Many people like, unflushed toilets and all that. That smell you cannot. But it's very easy. That same smell will be there when you actually smell that salt, or you just heat a sample of it. So ammonia will be released. पक्का ठीक है तो ये एक इंपॉर्टेंट है इसमें बाकी nobody can remember, so don't break your head. Let's go to the next one now. Flame color. This is very important. No running away from it. I would strongly suggest, if you have colored printers at home, very good. If you don't have colored printer, grab hold of a kindergarten student or go to Golchas and buy your crayons, and you color in a white paper before your exam and fix it. You cannot remember otherwise. Flame. First, let us understand what is a flame test all about. A flame test is like, we just take a wooden splint, okay, a small straw of wood, and you take a little bit of salt, and you will be putting it on the Bunsen burner which is on the flame, and you will see certain colors being emitted. That color is very, very particular characteristic of an element. No two elements can give you the same color. Now question arises, sir, does everyone emit color? Everyone emits a radiation. For someone's radiations are in the visible zone, which we see. For some people, we don't see. So what happens when you are heating a particular sample? What are you doing? You are actually supplying energy. So the electron absorbs that energy and starts getting excited. So the electron jumps from one shell to the other shell. And what did you understand in Bohr's postulate? Electrons, when they jump from one shell to another shell, absorb a definite amount of energy. That, if it is in the visible colored range, then you'll see it as light. If for some, so they say every element may not show a flame test. It's not that it's not showing a flame test, but it is absorbing. You're not getting the radiation in the visible zone. Understood? So why it happens? The flame test is because of a characteristic color, and the color represents the wavelength of that radiation. That radiation which has been absorbed by the electron in the form of energy when you were heating it, and the electron jumped from one to the other, and we call that as an excited state. Higher classes, you will understand, the electron starts occupying excited. Like your child, you've got 2 floors, 3 floors house, you stay in an independent house. The child, do you go every day to the top floor? No. But if you have a small kid in the house, the kid will any day run to the terrace because he's an excited kid. It goes up. The electron भी वैसे जाता है. ऐसे जाने में it will absorb an energy. That energy is shared. So let's see what it is. So in group 1, the group 1, we have got 3 type of cations that we will be testing for, and 3 elements: lithium, sodium, potassium. So they will be all what? Li plus, Na plus, K plus. Red, yellow, lilac. How to remember? I don't know. You have to remember. And you will forget it now. So it's always something like statistics formulas. Mug it up the day before. And for you, it's more harsh because you must have not seen them. Okay. Calcium. So something which you should know. Sodium will always be yellow. That's why we say that sodium lamps. Okay. When you must be traveling at night in your car and you must be crossing some factory or say some big industry, you'll always see boundary wall at night, and the boundary walls will have yellow lamps on them. So what do we say? That the boundary is sodium lamp lit. Sodium lamp will have a yellow color. Have you understood? Like airport outskirts and all, you'll always see old days yellow lamp. That is known as a sodium lamp's color. So sodium will give you a yellow, lithium will give you red, and potassium gives you a lovely lilac color. Exactly your t-shirt. Lilac. ऐसा ही आएगा. A little bit more that butterfly color. It will give you a lilac color. Group 2. In group 2, we need to be worried about calcium and barium. No magnesium, nothing. Orange, red, and light green. And others, copper, blue, green. Usually the question comes from the first 3. Because in first 3, you have a single tone color. In the other 2, you get dual tone color. Red, yellow, lilac. If you remember this order, then this order is as per the periodic table. Linaki. Linaki. Red, yellow, lilac. ये important है. बार-बार बोल रहा हूँ. This is important. So it will come as a 1-mark question in a 7-mark question or a 2-mark question. ठीक है? Clear? Our next job is to understand Aqueous cations. Aqueous cations means these are the metal salt solutions. So you have a metal salt solution. These also we call as wet test. Okay. If you go in higher classes, you'll understand something called dry test and wet test. These are all dry tests. आपको गीला करना नहीं पड़ता. You do not wet the item. These are what? Wet test. So out here what we'll do, we'll prepare sodium hydroxide solution, NaOH. You have got two reagents in this chapter, sodium hydroxide, ammonium hydroxide, NH4OH, NaOH. Although your book does not say them by formulas, they just write. So what are we going to test here? From group 3, we'll see Al3+, this is aluminium ion, calcium ion, chromium ion, copper ion, ferrous, ferric, and zinc. Okay? God is kind with you. So in NH4OH also, you will be testing for them only. Right? So what are the tests for it? So you get a white precipitate, means you take the solution of that salt solution and you straight away pour sodium hydroxide on a test tube. You take the salt solution, a sample of it, and you pour sodium hydroxide. When you pour sodium hydroxide, you get a white precipitate. Now the precipitate is soluble in excess, giving a colorless solution. There are two ways. Precipitate is anything that collects at the bottom of the test tube and does not dissolve. Totally it will be separate from the solution. You will see the clear solution and the precipitate below. Sometimes these precipitates can be dissolved by pouring excess solution, means with a dropper I gave 5-6 drops of sodium hydroxide, precipitate formed, and when I give excess of sodium hydroxide, whenever you get a precipitate, you are also supposed to check, does the precipitate dissolve on excess addition of the reagent? What is my reagent? Sodium hydroxide. So if it dissolves, then you are coming up with aluminium and zinc. ये confirmatory नहीं है. This is again predictive that these two may be present. Now you have to actually eliminate one or the other. The book, your syllabus doesn't talk about confirmatory tests that much. Now white precipitate, look at the next one. I got a white precipitate here. So I won't get it like this. So I've taken my salt. I don't know what is my salt. I put sodium hydroxide into it. I get a precipitate. My first thing will be that I add excess of sodium hydroxide. If it dissolves, then I'm narrowed down on these two. If it doesn't dissolve, then calcium. Clear? नहीं, dissolve होने से पूरा गायब हो जाएगा. It will be clear solution. Excess डालने से dissolve करने. That it's such a nice question you ask. This is where you need lab. So first you will see, like I hope you understood what is precipitate. Like you put sand in water, नीचे रह जाएगा ना, so it will be a precipitate. Once you add a little bit more of sodium hydroxide, and you're supposed to shake it a bit, then you'll see completely clear. I can see your face through it. So that's called dissolved. Dissolved means it's calcium. Okay, so far in these two, please understand the precipitate was white in color. So this is how you have to prepare your flashcard before the exam. Precipitate, white. Dissolves, aluminium and zinc. Doesn't dissolve, calcium. Very easy for me to narrate it now. Even if you ask me 1 week later, it will be difficult for me also to remember. But once you read it like this, even with my head turned away from the board, I'm clear. And if it is white in color and it doesn't dissolve, even on excessive addition, then it must be calcium. And tomorrow is my exam. I'm good enough to puke. That is how you have to prepare for this particular chapter. और कोई रास्ता नहीं है. ठीक है? So now we migrate from white precipitates to colored precipitates. Let's see. Green precipitate. Green. Green, don't go green here. You will never see a green as a single color. So no confusion. Which one? No, green as a single color you don't see here. So don't confuse. Green with sodium hydroxide. Green precipitate insoluble in excess. Now you'll see everything insoluble. That's why you are seeing the green color. अगर soluble हो जाता green color कहाँ से दिखता? You won't have seen it. So green color means chromium, chromium 3+. Light blue, blue means copper. Now at light blue, this you need to little bit. We will in the next test we will just keep this. Copper is something which is important for your syllabus. Precipitate is insoluble in excess. However, we will see when we do the ammonium hydroxide test, copper will first be insoluble, then slowly soluble, completely soluble. That is important for your exam. We'll come to that, okay? Then green precipitate, again, insoluble in excess, turns brown near the surface on standing. Brown bolte हैं iron, rusty. You have to link like that. Green precipitate in excess insoluble, that means chromium 3 plus. You get a green precipitate, but when you start pouring excess, it starts becoming brown near the surface on standing. Near the surface, it will be like a ring near the surface on standing. That means it is iron 3, ferric, iron 2, ferrous. Red brown precipitate, straight away you got red brown, ferric. अब देखो, इसको नहीं देख के भी हम याद कर सकते हैं. What are the three colors we spoke about? White, green, and red brown predominantly. And blue. White, green, blue, and red brown. White dissolves in excess. Then you should be what? Aluminium or zinc. Doesn't dissolve? Calcium. Then come to green. If it is green and it doesn't dissolve, chromium 3 plus. If it is green, the next one that we said, if it is blue, then it is copper. If it is green, doesn't dissolve, but on excess turns brown standing at the surface, then it should be Fe2 plus, ferrous. And if it is straight away reddish brown, it is ferric. Oh yeah, chart. On standing means I have my precipitate. So the precipitate is not going to dissolve. What is the color of the precipitate? Green. And you add excess, then on the surface means on the top surface, like a ring, while it is standing, ऐसे गिरा के नहीं, ऐसे खड़ा करके रखेंगे, on standing you should see brown. That means it is Fe2 plus. Red, yellow, lilac. Don't forget this. Red, yellow, lilac. Lithium, sodium, potassium. ठीक है, आसान ही है. I go to the next. Okay. The next is, before going to this one, let's understand this. If your salt is containing ammonium ion, as I told you, if a salt contains ammonium ion, then order should be good enough. Now, question is, sir, how do you know which salt contains what? I don't know. So when I get a salt, I will perform the order test whether the salt has got ammonia or not. I will straight away first heat it to see whether any ammonia fumes are coming or not, because once the ammonia fume comes, I need not go back to the, suppose you are doing a single salt analysis and you got ammonia, right? You're smelling ammonia right now. Then are you an idiot to perform all this green and all? Chahiye nahi na. Zarurat hi nahi hai. Why should you do? So ammonia gas is produced on warming. The ammonium cation does not form an insoluble hydroxide. So you don't check ammonium salt by producing, what do you call, sodium hydroxide on ammonia itself. However, it forms ammonia and water upon heating, and this ammonia gets dissolved in water. So it becomes a very weak, what do you call, a weak base, which is called ammonium hydroxide. Okay? Ammonia is always, so addition of dilute ammonia solution. Sir, what is dilute ammonia solution? Ammonium hydroxide, NH4OH. Ammonia gas dissolved in water is known as aqueous ammonia. The solution is only weakly alkaline, which results in relatively low concentration of hydroxide ions. Means, I hope you understand, alkaline means hydroxide. Hydroxide means OH. Is it clear? Hydroxide means OH. So ammonia will form a hydroxide, ammonium hydroxide. Now, aqueous ammonia can be used to identify again the same salts. Let's see the reaction with aqueous ammonia. White precipitate. Precipitate is insoluble in excess. Now look how beautiful it is. Go back to your first chart. What did the first chart say? The first chart said that when I use sodium hydroxide as a reagent, I get a white precipitate, and the white precipitate dissolves on addition of excess of sodium hydroxide. So I narrowed down on what? Aluminium or zinc. I don't know what it is, either of two. Now here it will bifurcate the two. Then take the sample again, and now you add ammonium hydroxide or ammonia solution. You get a white precipitate, and the precipitate is insoluble in excess. Then it is aluminium. And no precipitate or very slight, in fact in calcium you get no precipitate. They will give the salt of that concentration that you will get no precipitate. No precipitate means you are getting calcium. Now can you tell me what is the confirmatory test for any salt which contains calcium? If a salt contains calcium, then definitely I can do what you call flame test will not be that much supportive for me. So I'll take sodium hydroxide. I will put sodium hydroxide on the salt, and the salt will give me a white precipitate which will be soluble in excess, which means it is either calcium or it is aluminum. In order to now clear up, I will take the same salt solution, and what will I pour on it? Ammonia solution. If on pouring ammonia solution there is no precipitate, no change at all, it confirms that it is calcium. And if I get actually a white precipitate which gets dissolved in excess, then it is aluminum. Clear? Very good. Green precipitate. Okay. What was the chromium test in the previous one? The chromium test in the previous one was, yes.
I have one question, sir. So you do either of these two tests or both of them?
Okay, question, either of these two or both of them, depends upon whether you want to get confirmed or not. See, don't try to mug up. First, understand when you are doing the first test, that when we do the sodium hydroxide test on a white precipitate which was soluble in excess, you can't confirm it is ammonium or aluminum or calcium. You can say ye do hai, ye do mein kaun hai, that you can't say.
Okay, sir.
So to eliminate the odds, you have to perform the next test with sodium, with ammonia solution also. And with ammonia solution, if it is actually insoluble in excess, then aluminum. If on adding there is no change at all, then it is calcium. Our next check was for chromium. Try to remember what was chromium's test with sodium hydroxide. Chromium's test with sodium hydroxide was that you get a green precipitate. Was it soluble in excess? No, it was not soluble. So chromium is an ion which will not be soluble there also, which will give you a green precipitate and will be insoluble in excess of ammonia solution also. Chromium confirmed. Understood? Chromium present, chromium confirmed. Acha, we could have done this test also first. Suppose in this test, we are doing this test first, and we are getting that we are getting a green solution precipitate which is not soluble in excess. Chromium may be present. Perform the sodium hydroxide test. In that also, if you are getting green and it is not getting a, see, it's easy. Once you start reading it, it becomes easy, and you can see this video once again before your exam. At that time, video will be in non-Geo Hotstar, I agree. Okay. Okay, next one. Once again, light blue precipitate. Now, this part is a little bit important for us. Okay. Light blue was copper in that case, where in the case of sodium hydroxide, but the precipitate remained as precipitate. So you said copper might be present. Now, when you add ammonia solution to it, look at it. Precipitate is soluble in excess, giving dark blue solution. And this is shown pictorially separately in your book, means this is of significance to us. When you first add, cut out the dropper portion, you will actually get a jelly-like precipitate. If you add more of ammonia solution, the precipitate starts dissolving, and finally the color changes from light to dark, but it is a clear liquid, no more precipitate. This is the confirmation of copper. I again go back to the previous slide. Light blue precipitate with sodium hydroxide, insoluble in excess. What will I write if I perform this test first? I will write copper may be present. And if I perform this test, so if you tell yourself, if you want to test for copper, which one should you test? I will test this one. Why should you test that one? That one anyway doesn't confirm me. But in this one, if I get a light blue precipitate, the light blue will be, it says the light blue is a gelatinous light blue precipitate. Light blue is the precipitate one. Start adding more of ammonia solution to it. Slowly the precipitate starts mixing or gets soluble. Color changes from fade to darker. And finally you get a dark blue clear solution. Copper confirmed. So if anybody wants to test for copper, don't go by the sodium hydroxide. Go by the ammonia. It's far more easy. And then for your man ki tasalli, you can also do a little bit of sodium hydroxide also. You still get a blue which is insoluble in excess. Clear? Right. So what all we have attacked so far? Aluminium, then we have attacked calcium, then we have attacked chromium, then we have attacked copper. Okay. Our next one was green. Remember, Srinika, green. But when you add excess of sodium hydroxide, then the green precipitate turns brownish on the surface when standing. Don't forget, you asked a question also. So in exam time, don't forget. Yes, I'd asked a question on standing. It told It concluded that it has got Fe2 plus. So let's see what happens with ammonia gas as a solution. Ammonia gas solution. Precipitate is insoluble in excess, turns brown on the surface near standing. So that means Fe2 plus and chromium will behave the same with either of the reagent. Chromium is greeny greeny and this one is greeny greeny, more browny browny. Yo, Nidhi ma'am, clear or not?
Yes, sir.
Yes, everything becomes clear. Only thing is that you have to read it with open mind. Okay, next one. Red brown precipitate. Red brown precipitate, let's go back to sodium hydroxide. What was it? You get a red brown precipitate which is insoluble, means Fe3 plus ferric ions. Out here precipitate is insoluble, same Fe3 plus. And the final is white precipitate. This was something which was not there out there. So white precipitate means white precipitate is soluble in excess, giving a colorless solution. So it is zinc plus. Precipitate is soluble in excess. So if you are soluble in excess, then you get zinc. White precipitates insoluble in excess, calcium. So in zinc, what we are getting, the precipitate is soluble in excess and gives a colorless solution. So zinc is going to behave insoluble out there and soluble here. Just look here, zinc out here. Precipitate is soluble in excess. Sorry, soluble in excess means it will be behaving same in sodium hydroxide as well as in ammonia solution. Clear? याद हो जाएगा अभी. See, I don't expect you to remember tomorrow itself, but the way we have discussed it, I think if you take this particular table, this chapter is to be studied table to table. Nobody is going to ask you. A question will come only as a part, and then you have to remember who reacts with whom in what manner. Clear? Aluminium, zinc, calcium, then chromium, copper, Fe2 plus, Fe3 plus. Okay? So if we go back to this slide, then if you see, we have done flame, effect of sodium hydroxide, effect of aqueous, now variety of tests for aqueous and anions for gases. Okay, children, remember that this copper one is important. Ye yaad rakhna. This is important for you. Okay, next, I've made these two lines, these two rectangles. So these two rectangles are important for us from our exam perspective. Now the type of anions that we are discussing out here are carbonate, chloride, bromide, iodide, nitrate, sulfate and sulfite. Sir, is it possible for us to remember everything? May not be. Okay, few things you should know. Carbon dioxide. How do you check the presence of carbon dioxide? Carbon dioxide turns lime water milky. What is lime water? Calcium oxide is the tuna, CaO, that you buy in the market. Mix it in water and strain the water. The water becomes CaOH2, calcium hydroxide. Pass CO2 in it, CaOH2 plus CO2. You get something called CaCO3. And when you calcium carbonate, which is the white was the flakes. And if you add too much of calcium carbonate, sorry, calcium what do you call carbon dioxide, then that calcium carbonate can be dissolved. That is called degasification. Calcium hydrogen carbonate, yeah, that's why it dissolves. Very good, it's calcium hydrogen carbonate. Now, carbonate, add dilute acid, effervescence is seen as carbon dioxide is produced. Effervescence means once you add acid, then effervescence will be seen. That's carbon dioxide. Okay, chloride, acidified with dilute nitric acid and then add aqueous silver nitrate. This is a typical chemistry test oriented. I don't expect anyone to give this type of a thing on exam. A white precipitate is produced. So you have to remember dilute nitric acid and then add aqueous silver nitrate. Bromide, acidify with dilute. See, why is the same test same out here? Because all of them belong to the halogen family. Yes. So acidify with dilute nitric acid, then add aqueous silver nitrate. A cream precipitate is produced. White precipitate, cream precipitate. White stands for chloride. Sorry, chloride, yeah. Cream stands for bromide. Iodide, acidify with dilute nitric acid and then add aqueous silver nitrate, yellow precipitate. Iron will always give you yellow precipitate. Okay. So three of the, whenever you are checking for, so how should I remember this when I'm studying at home? I will make a flashcard which will be halogens are tested with dilute nitric acid and then treated with AgNO3, silver nitrate. And I'm going to get three type of precipitates. What are they? White, cream, and the next one is yellow. White stands for chloride, cream stands for bromide, yellow stands for iodide. ऐसे ही पढ़ना है, ठीक है? And when your chemistry exam is nearing, have one wall dedicated to you for your billboarding. That wall will keep on changing, like the cinema hall poster, now showing this movie. Your next exam is chemistry, all chemistry things comes up. Chemistry gone, all down, all physics things comes up. So these have to be there. You have to remember. और कोई रास्ता नहीं है. Next is nitrate, NO3, aqueous sodium hydroxide, then aluminum foil. Aluminum foil, have you understood? You take a small foil of aluminum, like which is present on your what do you call chocolates and all, chocolate wrapper, and you put that aluminum foil and then warm carefully. Ammonia gas will be produced. How to find whether it's ammonia gas or not? You will cannot stand like you'll cough out. As I told you, ammonia can make anyone wake up. If a person is usually not waking up after smelling ammonia, also after cardiac arrest and all, chances are that he is slept forever. Sulfate. Sulfate in solution. Acidify. So when you are acidifying, you're trying to make it sulfuric acid, okay? And then add aqueous barium nitrate or barium chloride. Okay, if you add barium nitrate or barium chloride, so it will form barium sulfate. This is a double displacement reaction. What is a double displacement reaction? In which two salts will swap their partners. So what is the white precipitate you are getting? The white precipitate will be the barium sulfate. You have got sulfate out here. You are first acidifying it, and then you are treating it with what? Barium chloride. So if you take barium chloride, it will give you barium sulfate. They will just interchange their ions. A white precipitate is formed. That shows it is sulfate. और एक बार फिर याद करने की कोशिश करते हैं. Carbonate, very easy. Acidify with dilute hydrochloric acid, you get effervescence. Carbon dioxide is present. Any dilute acid. These three, what was the test? Treated with dilute nitric acid and then treat with aqueous silver nitrate solution. You get three types of precipitate: white, cream, and yellow in the order of chloride, bromide, and iodide. What was for nitrate? Aqueous sodium hydroxide, then aluminum foil, then warm. You'll cough. Ammonia has come out. What was for sulfate? Acidify. Add barium nitrate or barium chloride. You're going to get a white precipitate. That white precipitate is barium sulfate. Barium sulfate always precipitates. And then sulfite, SO3 2 minus, the lower oxidation state. Add a small amount of acidified aqueous potassium magnate. This won't come to you. The acidified aqueous potassium magnate changes color from purple to colorless. This is actually purple in color. It becomes colorless. Nobody asks you this. इसी चार में नहीं, अगर ये पूछ लिया तो your bad luck is bad. Lose that 1 mark. Think that your bad luck was bad. Now comes to gases. Okay, hydrogen. Hydrogen, what is the test of hydrogen? Hydrogen will always give you a pop sound. Hydrogen gas is highly explosive. So if hydrogen is coming out, bring a lighted matchstick near the test tube. Hydrogen will always burn with blast. Have you seen one cracker which will actually go tup, tup, tup like that? It won't burn. Like when we burn matchstick in the presence of oxygen, it just burns, glows and burns. But in the case of hydrogen, it will burn with bursts. So we always say a matchstick will burn with pop sound. That is hydrogen. What is the test for oxygen? Well, oxygen is a big supporter of combustion. What is the atmospheric oxygen content right now? The atmospheric oxygen content is roughly 20%. If you increase the concentration to 40%, then if this is a pure cotton t-shirt, it will immediately catch fire. So oxygen itself doesn't burn. How many of you think oxygen burns? Oxygen does not burn. Don't be under that thing. Oxygen is a supporter of combustion. Is oxygen a flammable gas or a non-flammable gas? Non-flammable. Non-flammable. Oxygen is not flammable. Oxygen supports combustion. Always remember that. Oxygen is a non-flammable gas, non-flammable gas, non-flammable gas. Oxygen supports combustion. So much that whenever there is more oxygen in the atmosphere, we call it a oxy-enriched atmosphere. And you remember this example of mine. At 20%, you're fine to wear a cotton t-shirt. At 40%, this will immediately catch fire. and we're going to use that only. So take one again, wooden splint, and what you do, you ignite it. Ignite means you just ignite it with a glow. What is that? You have seen agarbatti, incense sticks, they are with a glow. With that glow, suppose the test tube is giving oxygen out. If you take a agarbatti or a wooden splint with a glow and you put it inside, it will immediately catch fire, because it is entering into a zone which is oxy enriched. Whenever you enrich with oxygen, the flame will be coming out. Clear? So that's done. Carbon dioxide turns lime water milky. All of us know these three are common tests. Hydrogen, pop sound. Oxygen, take a glowing wooden splint or anything inside and it starts to burn with a flame. Carbon dioxide turns lime water milky. Ammonia. Ammonia is basic. So what they say, turns damp red into blue. Basic means always it will be blue. Why did you use the word damp? A base or an acid will always show its property under aqueous condition. Why does the litmus paper turn red? Because it senses H plus ions, hydrogen ions or hydronium ions, H3O plus, acidic. Those ions will be released only in the aqueous medium. A dry litmus paper will never show any test, because to show the test, it has to sense either the OH or the H. Here we are interested in the OH. Ammonia as a gas will react with that damp paper. Dampness has what? Moisture in it. So the ammonia will become ammonium hydroxide. Ammonium hydroxide is a alkali, weak base, completely dissolves. So it will turn red litmus into blue. Is this concept clear? If I get a bucket of 100% concentrated sulfuric acid and I just pour it on your body, nothing should happen. But you'll say, how sir, I'll burn completely. Yes, you burn because you have got moisture in your body. If there was no moisture in the atmosphere and if the human body had no moisture, then sprinkling 100% concentrated acid should not do anything. The acid, to show that burning effect, should show acidic effect. Acidic effect means evolution or release of H plus or H3O plus. That can happen only when the environment is aqueous. Some sort of moisture is there. Got it? So if some, what do you call, acid falls on your hand, you get burned because it picks up the moisture of your skin. We are not dry. Oh yeah, sulfur dioxide. So how to test for sulfur dioxide? Sir, go and smell right in the exhaust manifold of a car, and if you cough and you get cancerous gases, it is sulfur dioxide. Don't write like that. The sulfur dioxide says colorless, very choking smell, red acidic, turns potassium dichromate. Potassium dichromate is K2Cr2O7. Again, little bit high level for you. From orange to green. Potassium dichromate is a reagent available in exam in the lab. It is orange in color. It turns green and turns acidified. Acidified potassium dichromate or acidified potassium permanganate. This we will also see in organic chemistry. These two reagents we'll be visiting again. Potassium permanganate from purple to colorless. So catch है इसमें. If you are using potassium dichromate, then you will become orange to green. Potassium permanganate, permanganite, these are always purple. Purple. Potassium permanganate. Has anyone seen potassium permanganate? Yeah, in lab is very common. पानी वानी में लेके आता है. Anyone who has ancestral house and you have got well, bore well or something, people keep on pouring. It is absolutely purple in color. So that purple will become colorless. If you are using acidified, see there are two reagents, potassium dichromate, potassium permanganate, KMnO4, K2Cr2O7. Acidified potassium dichromate means it will become orange to green, and acidified potassium permanganate means purple to colorless. We'll give you the test of sulfur dioxide, SO2 as a gas. No. This is a radical. The test is same, because here also that gas will be evolving out. But this is a test of a radical, polyatomic anion. This is the test of a gas. Okay. Next is chlorine. So in this section, oxygen को देख के रखिए, and also see water. Water पूछता है. Chlorine. Chlorine will be bleaches damp litmus paper. Bleaches damp litmus paper means it will make it colorless. Colorless if you have chlorine. I don't know how many of you people must have gone to a beauty salon at this age. You must have not done. If you go for applying bleach on your face, bleach pack, facial bleach pack, they will first apply the bleach on your palm, top wrist, and keep it for 2-3 minutes. Everyone's skin is not sensitive to the same extent. So if it starts itching, the beautician will not apply that on your face. Because once they apply on your face will start burning from inside. So bleach is always to be tested on your hand. So chlorine is a bleaching agent. It will bleach it off. Bleach matlab samajh gaya na, the color will go away. Water. Okay, tell me what was the test of water? Cobalt, chloride, cobalt 2 chloride and copper sulfate anhydrous. Yes. Turns cobalt chloride paper pink. Cobalt 2 chloride paper pink. Cobalt 2 chloride was anhydrous. When it sensed water, it sucked water of hydration, and hydrated salts are always colored. Therefore, you got a color in it. Another way to test is, if it is pure water, boil it at 1 atmosphere pressure. The boiling should happen exactly at 100 degrees centigrade. And one more is, turns anhydrous. Copper 2 sulfate, CuSO4, anhydrous, sucked in water, became what? CuSO4.5H2O. And that 5H2O will give you your blue color. And so copper sulfate and hydrated copper sulfate is also known as blue vitriol. Blue vitriol. That's it. There's nothing more. So I had to tell you in the form of a story, which I've tried to tell you. And now, when you're reading your book, I have tried to bring everything in one go. So this is much more compact.